Good morning friends. Today we are going to start with another type of digital voltmeter, that is successive approximation digital voltmeters. It is one another type of analog to digital converter, that is successive approximation type of digital voltmeters. Digital voltmeters are capable of 1000 readings per second or more, are now commercially available. These instruments generally use successive approximation converters to perform digitization. A simplified block diagram of such a digital voltmeter is given in the figure. At the beginning of the measurement cycle, a start pulse is applied to the start-stop multivibrator. You will see a start and stop multivibrator over here. This set a 1 in the MSB of the control register and 0 on all bits of the less LS bits. Assuming an 8-bit digital control registers, its reading would be 1000. This initial setting of the control register causes the output of the digital to analog converter to be output of analog to digital converter compared to the unknown input by the comparator. If our input voltage is larger than the converter reference voltage, the comparator produces an output that causes the control register to retain the one setting in the MSB, and the converter continues to supply its reference output voltage of half volt. The ring counter next advances one count, shifting a 1 in the second MSB of the control register, and its reading becomes 1100 and 0000. This causes the D to A converter in the increase its reference output by 1 increment to 1 by 2 volt plus 1 by 4 volt, and another comparison with the unknown input voltage takes place. If in this case the accumulated reference voltage exceeds the unknown voltage, the comparator produces an output that causes the control register to reset its second MSB to 0. The converter output, that means if you want to read 5 volt initially, it will set to check whether it will be 5 volt exactly or not, and then if it is not, then it will set 2.5 ratings, and 2.5 is set first, then 1.25 is set, then thirdly 0.625 is set, and so on. Like this point, it will approach towards the final settings. The counter output then returns to its previous level of half volt and awaits another input from the control register for the next approximation when the ring, and so on. It goes measuring successively. During the start and stop pulse, your voltage is counted. Let me to give you in detail or how it works. Initially, input is given to input attenuator. It holds the circuit, sample and hold circuit is there, which holds the input. Suppose it is 4 volt input, it holds the 4 volt over here. 4 volt comes to this point. Now V out is 5 volt and it is not equal to this, so it will set a gate pulse of 0. It will set a lower gate pulse at 0. Then again, as it has set its readings to less than 5, it set its reading to less than this 0. Again its 4 volt is compared with 4 volt exactly. Here it will reset, instead of 5 it will come down to 4, and once it is 4, gate becomes open positive, and correspondingly output is measured on the control registers. Output is taken, ring control registers, and see if our readings are 4, initially it is set to 1, then suppose our readings are 1 readings, initially it will find out 0.5 plus 0.25 plus 0.125 plus 0.06650 and so on. So it will try first point for 0.5, it will try next for 0.25, then 125 get added and 0.650 is added. Overall it becomes 0.95 and so. If there are more number of digital displays, digital bits, then it will come to nearest approximate level. This is what a successive approximation is. If there are, it will set its 0, 1, 0, 0, 0 and 0, 0, 0, 0 like this. It will set like this. Again it will set, if it is not working, it will set next level, lower level, and that successive approximation will work. With input voltages other than DC, the input level changes during digitization and decisions made during conversion are not consistent. To avoid this conversion error, sample and hold circuitry is placed in the input directly following the input attenuator and amplifier. In its simplest form, the sample and hold circuit can be represented by a switch and a capacitor. In the sample mode, the switch is closed and the capacitor charges to the instantaneous value of the input voltage. In the hold mode, the switch is open and the capacitor holds the voltage that it had at the instant the switch was open. If the switch drive is synchronous with the ring counter pulse, the actual measurement and conversion take place when the sample and hold circuit is in the hold mode. In a practical circuit, the simple switch is replaced by fast acting transistor switches and the operational amplifier is added to increase the charging current into the capacitor. We will see next part in the next lecture. Thank you very much.